linear equations in standard form. So our objective is going to be to connect. We're going to be connecting solutions of equations to the points on their graphs. Okay, so first we need to talk about what is a linear equation in two variables. So far, any equations we've dealt with have not been linear equations because they only have one variable, an x or a y, so far when we've been solving them. Okay, today we're going to be dealing with linear equations in two variables. Important word there being two. So there's going to be two different variables. And it's linear. An equation can be written, a linear equation is an equation that can be written in the form ax plus by equals c. So if I can write it as, basically this is saying some number times x plus some number times y. If that equals some other number, then it is a linear equation in two variables. Important to know that a, b, and c are just numbers, and a and b are not both 0. Now we're going to look at what happens when one of them is 0, but they can't both be 0. For example, okay, if a was 3x, plus and b was 5, equals c, which is 10. So 3x plus 5y equals 10. Again, this a, b, and c are just numbers, but we write it as a literal equation, if you remember from a few sections ago, denoting that a, b, and c can be any number. Okay, so we have 3x plus 5y equals 10. So here in task 1, we have a table of a bunch of equations that are linear and some that are not. Not all equations are linear. Okay, so our first bit is we want to look at the linear ones and we want to write them in standard form. This is what is called standard form. This guy right here is what is called standard form. Okay. ax plus by equals c is standard form for a linear equation. So if we look at these and we look at this first one, 2x minus 5y equals 8, it's really close. The only thing we're missing is it should be a plus. So we can rewrite that as 2x plus a negative 5y equals 8. So then my a, my b, and my c, my a is 2, my b is negative 5, my c is 8. Okay, so this one didn't require a whole lot of extra work. I just had to rewrite that negative as plus and minus. So that's in standard form. This next one is going to take a little bit more work. So there's the first one. We'll go ahead and circle it. We're done with that one. Next one, we have y equals negative 3x minus 3x minus 2. Okay, so standard form, I need my ax and my by to be on the same side. Notice where that equal sign is. Here, my y is on this side, my x is on this side. So I need to move my x over here. So right now it's a minus 3x, so I'm going to add 3x to both sides. And again, this is a positive y because there's nothing in front of it, it's just a 1. Okay, so now on this side, my minus 3x plus 3x, that's 0. So now on this left side over here, I've got a positive 3x plus a positive y equals negative 2. There's my ax, plus my b would be 1 in this case, right? Because there's nothing in there. And then my c would be that negative 2. All right, so we're done with that one. Next one, this guy right here, is very similar issue. My x is on that other side. So this next one, we've got 4y equals negative 1/2 x plus 5. So I need this x to be on that side. Right now it's a minus 1/2, so I need to add a 1/2 x to both sides. And again, that's a positive 4y. So I'll have 1/2 x, because we want always my x to come first, plus 4y equals these minus 1/2 x, positive 1/2 is 0, so equals 5. My a in this case would be the 1/2. My b is 4, my c is 5. Next one is a little wonky, but it's all right. Pi minus y. Remember, this pi is not a variable, it's a number, slightly more than 3, less than 4. approximately 3.14, but not exactly. So it's just a number. It's like my C, it's just like a number like my -2 over here, or like my 5 over there. So again, I want my X's and Y's. I need my X's and Y's all on one side together. My X is here, my Y is here, so I need to move my Y over to the same side as my X. So I'm going to, it's a negative Y, so I'm going to add a Y to both sides. So on my left side, I have 2.5x plus y. Minus y plus y is 0 equals pi. There, now that one's done. My A is 2.5, my B is 1, and my C is pi. Okay, so now I have them all written in standard form. Let's look at the not linear equations. Explain why each equation in the right column cannot be written in standard form. Okay, so if we look at each of these, we have 2x minus y to the third. That y has an exponent. Standard form, the exponents on both my x's and y is, well, we don't have it written in, but really the exponent is 1, right? They're to the first power. If you look at each of these, here, this y has an exponent of 3. Here, my x and y both have exponents. Here, my x and y both have exponents. Here, my x and y both have exponents. So explain why each, the variables, have exponents other than 1. Linear equations, the variables only have an exponent of 1. It's x to the first, y to the first. Okay, just one single x, just one single y. So the variables have exponents other than 1, which makes them not linear. Okay, the graph of a linear equation is the set of all pairs of x and y values that satisfy the equation. So now I'm going to take this equation right here, and I'm going to type it into Desmos. Okay, so here, I typed into Desmos. I just typed it in, 2x minus 5y equals 8. And it gives me this line. What this line is showing me is all the x and y values that work in that equation. For example, when x is 4, here, when x is 4 and y is 0, that equation is true. And if we go look in this equation, the 2x minus 5y equals 8. I'm going to write it down here. 2x minus 5y equals 8. And we had the point 4, 0. When x is 4, 2 times 4, and y is 0, it makes this equation true. 2 times 4 is 8, 5 times 0 is 0, 8 minus 0 is 0. Yeah, it does work. But that's only one of the infinite number of points that will work. Other points that will work. Okay, one nice thing about Desmos, I just put my cursor on that and I can trace every single one of these points will work. 6.62 and 1.048 will work. Other nice ones here, this one right here is like 9.92 will work. Here, this one, the point 0, negative 1.6. Here, the point -1, -2 works. Here, the point -6, -4. What I mean by it works, the point -6, -4. When I replace x with -6, 2 times -6 minus 5 times -4, it does equal 8. 2 times -6, -12, plus a negative. -5 times -4 is positive 20. That does in fact equal 8. -12 plus 20. So the point -6, -4 does work. So when it says here, the graph of a linear equation is the set of all pairs x and y values that satisfy the equation, they make it true. Okay? And there's tons of points that don't make it true. For example, the point 1, 1. Desmos can also graph points. If I type it in as 1, 1, the point 1, 1 is not on the line. So guess what? The point 1, 1 doesn't work. Okay, if I come in here and I try the point 1, 1 in this equation, it won't work. 2 times 1 minus 5 times 1, does that equal 8? Question mark. 2 minus 5? Nope. Doesn't work. Okay, so to be able to graph a linear equation, we're going to create a table of values. Okay, so what we're going to do is we're going to create an X, Y table and find points that work in this, and then we're going to graph them. Okay, so first, again, a bit about graphing. Graphing, we have two axes. If you remember this, the horizontal is called the x-axis. The vertical is called the y-axis. The point here in the middle is called the origin, and that's the point 0, 0. Basically, it's two number lines that meet at this point 0, 0. An ordered pair, x, y, is what is called an ordered pair because the order matters. X comes first, y comes next. You always count your x. Again, your X is your left and right first before you go up and down. Kind of like if I want to get up on the stage, I have to run over to it first before I go up. So you always have to go over before you go up, okay, when graphing ordered pairs. Just a little bit of crash course in graphing. All right, so I've got my XY table. So now I'm going to be like, okay, like what points do I try? Okay, we just start putting in some points. I always like to start with our simplest points like 0, 1, 2, 3, but it's always good to try some negatives too. So I'm going to start with an x is 0. So I need to put an x is 0 in here. 2 times 0 plus y equals 4. 2 times 0 is 0 plus y equals 4, so y equals y4. Okay, now let's try 1. 2 times 1 plus y equals 4. 2 times 1 is 2, plus y equals 4. Now I need to subtract 2 from both sides. Y equals 2. Okay, so I can now start graphing these points. I have the point 0. So left and right, 0, up 1, 2, 3, 4. That's going to put me right here. There's my point 0, 4. I'm going to label it. We've got the point 1, 2. So over 1, up 1, 2. So there's my point 1, 2. Okay, so I could at this point connect the dots, right? I can grab my ruler. I don't know if you'll be able to see the ruler. I put my ruler up there, connect the dots, and then I can draw in my line. Okay, but, okay, what if I'm wrong? So we're going to need more than 2 points. So let's go ahead and let's find some others. Let's try -1. So 2 times -1 plus y equals 4. -2 plus y equals 4. So add 2 to both sides. Y equals 6. So at the point -1. So -1, 1, 2, 3, 4, 5, 6 would put me right here. All right, well, that looks like, oh, -1, 6 is that point right there. So it looks like they're all kind of on that line. And I could try a few more. I could try an infinite number. One thing I want you to notice is when solving these, I kind of went through the exact same process, right? I plugged it in and then I added or subtracted the same thing from both sides. You can save yourself a lot of work. Save yourself some work. Solve for y first. Meaning I can take this original equation, this 2x plus y, and I'm just going to subtract 2x from both sides. So y equals 4 minus 2x. Now it's much easier to plug points in. Let's say I want to now plug in a 4. I plug it into this new equation right here, and I get y, 4 minus 2 times 4. Well, that'd be 4 minus 8, -4. Doesn't require any solving, it's just more like plugging in. So I get the point 4, -4. So now I come over here, 4, 1, 2, 3, 4, down 1, 2, 4, puts me right here. And again, those look like they all line up. So now I grab my ruler, I plug it on there, connecting all those points, and I draw my line. Whoop. And when you draw a line, you have it go all the way through your axes. I really probably should have had that go farther up there. Have it go all the way through. Don't just connect the points because this line does keep going. This line does not stop here. The line does not stop here to here. Don't just connect those two dots. It keeps going for forever because it's an infinite number of points. Okay. All right. Now I want you to go ahead and answer this question. Would the points 5, -6, and -4, 10 be points on the graph of the above linear equation? Explain. So this is your turn. All right, next we need to talk about intercepts. There are two intercepts. There are basically two places where this function intercepts or goes through one of my axes. We've got this point here and this point here. The point where it crosses the x-axis we call the x-intercept. The point where it crosses the y-axis we call the y-intercept. So the intercepts are the points at which it crosses. Point where the graph crosses the x and y axis. So we have two different types of intercepts. We have an x-intercept and a y-intercept. Okay, so if we come and look at this graph that we just did, if we notice we actually found, here at this point 0,4, we found the y-intercept. The y-intercept is the point 0,4. And I want you to notice, look at the x-coordinate of that point. The x-coordinate of that point is 0. Hey, and we didn't actually find the x-intercept, but it's right there. We can graph the ordered pair for that. That looks to be the point 2, 0. And again, look at the y-coordinate for that. The y-coordinate is 0. So on my intercepts, at the x-intercept, the y-coordinate is 0. Okay, so it's going to have only an x. It's going to be x, comma, 0. At the y-intercept, okay, the x-coordinate is 0. Sorry. Tried to put the word is and 0 together. Is 0. So it's going to be the coordinate 0 and just a y. So to find the x-intercept and the y-intercept, we're going to let the x-coordinate and y-coordinate be 0. So task 3, it says consider the linear equation. So we have 2x minus 3y equals 6. When one of the variables is 0, the other variables can be found as shown. So we're going to take this equation, 2x minus 3y equals 6, and we're going to let x be 0. So we'd have 2 times 0 minus 3y equals 6. 2 times 0 is 0, so we have negative 3y, don't forget the negative, equals 6. We're going to divide both sides by negative 3, y equals negative 2. So when x was 0, y is negative 2. So we can come in and we can graph that. Sorry, it's not snapping like it's supposed to. Okay, so we're going to graph this point, the point 0. So we go left and right, 0, down 2. Right there. So that looks like that is the y-intercept. If you can't remember which one you're finding, let one be 0, graph it, and you'll be able to find from there. So now let's take the same equation. And instead of letting y, let's let y be 0. 2 times x minus 3 times 0 equals 6. 2x minus 0 equals 6. Divide both sides by 2. X equals 3. So x is 3, y is 0. So we go right 3, 1, 2, 3, up and down 0. So there's my point right there. So there is actually my x-intercept. So I was able to find my x and y intercepts, and those are actually the easiest way to graph a line, because then I can just come in. Zeros are really nice to work with. I can just come in and draw that line in, connecting those intercepts. So there is my line. So then from that, I can now find a bunch of other points if I want to. I mean, I can see here, hey, it goes through that point right there. So there I have another 1, 2, 3, 4, 5, 6, 2 is another solution. Here's another solution. It looks like maybe 8, 4. I can find all different kinds of solutions just by reading off points on this graph. There's one, there's one. You always want to go for the nice ones. I mean, we could do halves and stuff, but that's a whole lot easier.